From the given figure, what is the length of the red line? Line constructions, geometric theorems, sine rule, cosine rule, and triangular rules are used to solve this question. Solution. Label points A, B, C and D. Consider triangle ABC. By cosine rule, the square of line AB equals the sum of the square of line AC and the square of line BC minus 2 times the product of line AC and line BC times cosine C. Substitute the values of line AB, line AC and line BC. We have that the square of 4 equals the sum of the square of 2 and the square of 3, minus 2 times the product of 2 and 3, times cosine C. Make cosine C the subject of the formula. By moving other numerical terms to the side of the square of 4. Make sure that you apply the sine rule of arithmetic operation as the number or variable crosses the equal sign. Divide by the product of 2 and 3 times 2. This procedure will make cosine C the subject of the formula. Hence, cosine C equals the sum of the square of 2 and the square of 3 minus the square of 4. All divided by 2 times the product of 2 and 3. Which equals to -1 divided by 4. It implies that C equals the cosine inverse of -1 divided by 4. The result is equals to 104.48 degrees. By sine rule, line BC divided by sine A equals to line AB divided by sine C. Substitute values and we have that 3 divided by sine A equals 4 divided by sine 104.48 degrees. Cross multiply and solve for sine A. Sine A equals to 3 times sine 104.48 degrees. All divided by 4. Now we have to find the sine inverse of the equation to obtain the value of angle A. We will use the theorem that the sum of angles in a triangle equals 180 degrees to find the value of angle C. Of triangle A, B, C. Take the sine inverse of the equation. A equals the sine inverse of 3 times sine 104.48 degrees. All divided by 4. Which equals to 46.57 degrees. But the sum of angle A, angle B and angle C equals 180 degrees. It implies that angle B equals 180 degrees minus the sum of angle A and angle C. Substitute values and we have that angle B equals 180 degrees minus the sum of 104.48 degrees and 46.57 degrees, which equals to 28.95 degrees. Hence, angle B equals 28.95 degrees. After simplification of substituted values. Let us find the value of the radius of the circle that will help us obtain the values of other parameters needed to solve for the required length of the red line. Locate the center O of the circle. Join line O, A and line OB. Each equals r, the radius of the circle. Reflex angle AOB equals 2 times angle ACB. It is because the angle at center is twice that at the circumference of the circle. We can now substitute the value of the known angle ACB to find the value of the reflex angle AO to B. Reflex angle AOB equals 2 times 104.48 degrees, which equals to 208.96 degrees. From triangle AOB, angle AOB equals 360 degrees minus 208.9 degrees, which equals 151.04 degrees. It is because the sum of angles at a point equals 360 degrees. From triangle AOB, using cosine rule, the square of line AB equals 2 times the product of the square of r and 1 minus cosine 151.04 degrees. Substitute values and we have the equation shown on the screen. Make the square of r the subject of the formula. Hence, the square of r equals 4.266762234. After simplification of substituted values. Take the square root of both sides of the equation. We have that r equals the square root of 4.266762234. We can find the value of angle BAO since angle OAD equals to 90 degrees. This is true by applying the circle geometric theorem. Let angle BAO equals theta by sine rule. Line OB divided by sine theta equals line AB divided by sine 151.04 degrees. Substitute values and we have that the square root of 4.266762234 divided by sine theta equals 4 divided by sin 151.04 degrees. Cross multiply and make sine theta the subject of the formula. It implies that sine theta equals 0.25004204. After simplification of substituted values. We can now find the value of angle theta by solving for the inverse of both sides of the equation. Find the sine inverse of the equation. Theta equals the sine inverse of 0.25004204, which equals to 14.48 degrees. But angle OAD equals 90 degrees. It is because line drawn from center O of a circle is perpendicular to the tangent line at the point of tangency. Some of the values we already obtained are displayed at the left-hand side below the given question. This signify that angle OAD equals 90 degrees, which equals the sum of theta, 46.57 degrees, and angle CAD. Hence, 90 degrees equals 14.48 degrees plus 46.57 degrees plus angle CAD. Therefore, angle CAD equals 90 degrees minus the sum of 14.48 degrees and 46.57 degrees, which equals 28.95 degrees. Also, angle ACD equals 180 degrees minus 104.48 degrees, which equals 75.52 degrees. It is because the sum of angles in a straight line equals 180 degrees. Consider triangle ADC. The sum of angle CAD, angle ACD and angle CDA equals 180 degrees. Substitute values and make angle CDA the subject of the formula. Angle CDA equals 75.53 degrees as shown on the screen. Use sine rule. Line AC divided by sine 75.53 degrees equals line C, D divided by sine 28.95 degrees. We can now find the required length of the red line, which is equals to line CD. Substitute values and we have that two divided by sine 75.53 degrees equals line C, D divided by sine 28.95 degrees. Cross multiply and solve for line CD. This implies that line CD equals 2 times sine 28.95 degrees divided by sine 75.53 degrees, which equals to 0.99980766. Therefore, the value of line CD, which the required value of the length of the red line equals to 1.0 unit to 1 decimal place.